Today we are going to improve our Gauss naive function. Okay. And let's remind ourselves of why we were calling our function that performed row operations naive. Okay. So we were considering it naive because if we were in this situation right here, we'd be out of luck. And so what situation is this? Well, you can see that we've already taken pivot 1 and eliminated everything below it. Okay. And now we're on to our second pivot, and we'd like to eliminate everything below it. Okay. But remember, to get the factor that we would want to use to do this elimination here, it always is dependent on dividing by the pivot. So like if I wanted to eliminate this right here, the factor that we would have computed would have been 1 divided by 0, which would be a problem. Okay. Well, the question is, what are we going to do about that? And the answer is we can swap some rows, right? One of our row operations is row swaps. And while it does seem like, hey, I could, swap these two or these two, right? It's up to us. The question is which one to choose. Okay. Well, we'd actually like to choose the bigger one. Okay. And by using the larger one here, we are going to end up with less round-off error. And there's a great example in the textbook on page 261 that demonstrates what happens if we don't make this row swap for the largest element. Okay. It'll show you that it can lead to round-off errors. And is what I'd like us to do is switch over to Matlab, and we are going to code in these pivots. Here we are, and I am going to clear what I have here. Okay. So what I have right now is the Gauss naive function. We are going to save this as something else. We are going to save this as Gauss Pivot. Which means we need to change the name of the function. And we actually don't need to do much to this function. We're just going to add a little section to this, and we're going to add it right after our 4k is equal to 1 to n minus 1. We're going to add it right in here. And the reason that we're going to add it right here is you can actually see we have this commented here. This k equals, this is counting what pivot we're on, okay, or specifying which pivot we're on. Okay. And so once we hit a pivot, is what we'd like to do is make sure that that pivot is the largest number in its column to reduce round-off error and to make sure that we don't have division by 0. All right, so we are going to start off with just commenting in what we're doing, which is partial pivoting. If we wanted to do more than partial pivoting, you might be wondering what that is. That would be if we were to be swapping around rows and columns. Okay? But it ends up that most of the benefits are going to come just from partial pivoting, and so we don't need to do full pivoting, or sorry, complete pivoting. Okay. All right, let's go ahead and put in our next line. Okay. So we want to take the max of the absolute value, of course. All right, the sign's not going to be an issue here. Okay. And let's maybe go and look at what we had in OneNote here again to maybe help us out a little bit. Okay. So when we were on this pivot, is what we wanted to do was search for numbers below it that were bigger. Okay, that's all, below it. Okay, that's the key. But in this specific column, column K. Right. And the idea of why we don't want to pull anything from up above here is we've already finished using this pivot here to do the elimination below it. Okay. So let's go ahead and go back to Matlab and just use this fact that we're in column K and we're just looking at the elements after or at the pivot and after. Okay. So if we're at the pivot, that would mean we're in row K, and we can go all the way up to row N. Right, this is an n by n system, and then we are in column K. All right, and now the max function can output two things for us. So keep in mind, this is just a row in a matrix. So if this is just a row, okay, then we can think about it as just a vector. Okay, so if I type in big here, this will be the largest value that's going to pop out of the values that we're looking at. And if I put comma I here, I is going to be the location in that vector. Okay. But it is important to note that, remember, the indexing for this vector is going to start at 1 and not at 0. Okay. Right, that's how vectors work in Matlab. Okay. All right, and so next I'm going to suppress this. Okay. And then this next part is going to seem a little confusing at first, but it's because it's going to take care of two things at once. So we have IPR is equal to I plus K minus 1. Okay. And I'm going to actually write in the beginning of an if statement here to help us make sense of this. So if IPR is not equal to K, then we'll do something. Well, let's note to ourselves, what would it mean if IPR was equal to K? All right. Well, let's maybe even ignore, or maybe let's write this in a slightly different order. Let's just start off with saying it was K. So if we said it was K, that would mean that we're just on the pivot that we began with. If we say plus I, note that what if the biggest element in that column was the pivot itself? What would that make I? Well, remember, the indexing starts at 1, so that would make I equal 1. Okay. So this is actually one ahead of where we want it to be. We want IPR to tell us where the largest element is. And so if it was at the pivot, again, this would put us 1 too far. So to compensate for this, we need minus 1. And let's maybe think about this a little further. Let's say it was actually one element past the pivot. Okay. If it was one element past the pivot, well then I would be 2. And so this would put us at K plus 2. So that would put us, again, 1 too far ahead. So we need this minus 1 in there to compensate for that. Okay. For the fact that vectors in Matlab start with an index of 1 and not 0. Okay. So there's that part taken care of. Okay. So that's all this is checking. Okay. So as long as the max does not occur at the pivot, we are going to perform a row swap. Okay. So when we do a row swap, we're going to be concerned with 2 rows and all of the elements in those rows. Okay, so that's why I have the colon here. And I put brackets in here, you might be wondering, because we're going to be talking about 2 different rows. We're going to be talking about row K, because that's one of the ones we're going to move. And the other one is going to be IPR, the one that has the largest element in it. Okay. And what do we want to do with this? Well, we'd like to, again, swap these rows. So is what's going to happen here is we are going to make this aug IPR, comma, K, and then we will go ahead and make sure that we include every element in those rows. Okay. And so let's think about what this is saying for a second. Okay. This is saying that we're going to take row IPR and row K, and we're going to swap them. Okay. That's all this is saying. Okay. All right, and then we can go ahead and we can end this if statement. All right, and this little section that we added here is all we needed. Okay. So what we'll do next is we'll go test this out. All right, so I've switched this back to a system that we were looking at before, and let's just again compare this. So let's say x sub p for the fact that we're going to be pivoting, and let's say Gauss Pivot a comma b, and we'll compare all of our outputs here, and we'll also see if we get any error messages because maybe we made some typos. Okay, let's go ahead and run. All right, and so these all seem to be giving us the same thing. Let's hit format long, see if we can see any differences. Format long. Okay. So actually, at least for the system that we happen to be working with, the tools we have made are actually doing better than this one here, than the backslash. The last thing I'd like us to do with this new function is at least see in at least one example that it does indeed reduce our round off error. And we're going to do this with a small system, so you could imagine if we had a large system we were making lots of calculations, that build-up error might add up a little bit. Okay, so I'm going to change B here a little bit, or A and B a little bit. Let's do 0.0003 and then just 3, and then we'll do 1 and 1. There we go. So there's A, and then B is just going to have 2 entries in it, 2.0001 semicolon 1. Okay, and I'll just get rid of the backslash one here. So you'll be able to tell what the answers are, and is what you'll see when we hit run here in a second is that the Gauss naive is still pretty close for this system. Okay, but you'll be able to tell that there is, again, some round off error. So let's go ahead and hit run. Okay, so I actually, before I pull this up any further, do note, this is the decimal approximation you'd expect to see if the answer was 1/3, comma, 2/3. Okay, and that is what the answer is. But let's scroll up and see what we get numerically without pivoting. So this was with pivoting. Without pivoting, pretty close, but you can see out here we finally encounter some round off error. All right, and that is it for today.